In this session, we are going to discuss regression analysis, one of the very important and interesting topic within machine learning. Let us see what is it all about. What do you think? Is there any association between the hours of study, how many hours you're studying, and the final marks that you get? Is there any such association, or there is no such association?
There is.
Some people would say there is some association. Some people would say no, there is no such association. What if I ask you this question? Is there any association with temperature, between temperature and the sweater cells? Are these two variables associated?
Yes, sir.
Yes, sir.
Here, there is no question. All of you would agree. As the temperature increases, as it gets hotter and hotter, the sweater cells goes down, isn't it? As the temperature decreases, as it gets colder and colder, the sweater cells goes up. Is it fair to say that temperature and sweater cells are always associated with each other?
Yes, sir.
Yes, sir.
Is there any association between temperature and ice cream sales? Same temperature and ice cream sales. Whenever we come to this situation, whether there is any association between two variables or not, generally we think intuitively based on whatever we know. Even here, hours of study and the grades. Whenever you want to find out whether there is any association or not, let the data tell us that story. What is the data saying? If you want to know whether hours of study and final marks that student get, are they related or not? Let X be the variable, which is indicating how many hours a student is spending on studies per week. The average number of hours a student is spending per week. Let Y be the variable that is giving us the grades or the marks that each student is getting. Maybe take 1,000 students. Take 1,000 students. For all these 1,000 students, the first variable is average hours of study. Ask them how many hours they are studying on each and every week. Measure that. Keep it here. Wait for 3 months. You will get their marks. The marks are indicated here. Once you have the data, now everything is clear in front of you. Data is there. Then, is there any statistical measure that will tell us, yes, these two are associated and they are associated by this much? Is there any statistical measure that will quantify whether two variables are associated or not? Yes, there is a statistical measure called correlation coefficient. What is correlation coefficient? What does it do? Correlation coefficient, it tries to quantify the strength of association between any given two variables. The correlation coefficient formula is covariance of xy divided by square root of variance of x into variance of y. Variance of x, we already discussed. You remember that in fundamentals of statistics, we discussed what is variance of x. Variance of x will tell us what is the dispersion within x. Within x, how x is varying. Yes or no? Are you clear on this? Variance of x. This is variance of y. Within y, how y is varying in itself. What is variance of y? From its mean, how the values of y are moving. Variance of x, variance of y in the denominator. In the numerator, you have covariance of xy. xi minus x bar into yi minus y bar. What does this covariance of xy tell us? It is together variance. Variance together. Xi minus x bar, which means, in simple words, whenever x is moving a lot from its mean, is y also moving a lot from its mean? If yes, then covariance will be very high. Whenever x is moving a lot from its mean, if y is not at all moving, then covariance will be very low. Covariance is kind of together variance, how x and y are moving together. That is given by covariance. So in the numerator, you have covariance of xy. In the denominator, you have square root of variance of x into variance of y. Okay. That is known as correlation coefficient. So you calculate a correlation coefficient. If the calculated value of correlation coefficient comes out to be 0 to 0.25, then you will say there is a negligible association. Negligible. If it is 0.25 to 0.5, then you will say weak association. 0.5 to 0.75, moderate association. 0.75 or above, then only you will say, yes, these two variables are very strongly positively associated. Our decision should be driven by the data. Based on the data, we calculate the correlation coefficient and we say that these two variables are associated with each other or not by looking at the correlation coefficient. Is it possible that x comma y variables, these two variables, always they have to be always positively correlated, or can there be a negative relation between them? Inverse relation. That means as x is increasing, it is related to y, but it is inversely related. As x is increasing, y is decreasing. Is that possible?
Yes, sir.
Is it
The
possible?
same
Give me an
example
example. In fact, the same
Sure.
one, temperature versus sweater sales. Supply versus demand. As x is increasing, y may decrease sometimes. In that case, correlation will be negative as well. Correlation 0 to minus 0.25, negligible negative. Minus 0.25 to minus 0.5, weak negative, minus 0.5 to minus 0.75, moderate negative, minus 0.75 to minus 1, strong negative correlation. So the correlation value varies between minus 1 to plus 1. If the correlation is near to minus 1, then strong negative association. Correlation is near to plus 1, strong positive association. Correlation near to 0, no association. If there are two variables, if you want to know whether those two variables are associated with each other or not, you can do that by looking at the correlation coefficient. Tell me one thing, if the correlation coefficient value between xy is 0.2, between xz is minus 0.8. Now x is strongly associated with what? Is it associated strongly with y or z?
Y.
Sir, Z.
Z.
XY correlation is, yes, it is positive, but what kind of positive? It is between 0 to 0.25. What do we call this as? XY and R?
Negligible
Negligible positive versus negligible positive versus
strong negative.
strong negative. Then what did I ask you? X is strongly related with what? Did I ask like negatively or positively? Doesn't matter. Depending on the nature of the variable, the sign may vary. Do you agree with that? Always a negative sign doesn't mean it's a bad signal. Are you with me? Depending
Yes,
on the
sir.
type of the variables, maybe two variables are positively related or maybe two variables are negatively related. Is there a rule that every variable in this world has to be always positively related with other one? There's no such rule. Okay. So what I would say is, though it is negative, there's X has a stronger relationship with Z. It's not having that much stronger relationship with Y. So that's the story of correlation coefficient.
Okay.
Whenever you have formulas like this, I'll give you time to ask the question. Whenever you have formulas like this, what did I say? You don't need to memorize any of these formulas. All of you are on the same page, right? There's no need to memorize any of the formulas. There is no situation that you will get when you're working where you have to write down the formula or derive anything. Do you think you're going to calculate by substituting everything in this measure? Or do you think you're going to use a tool or a function that has ready-made everything? You're going to just pass on X and Y. How are we going to do when you're working on actual real data sets? There we will be simply using functions, isn't it? There's no need for us to actually memorize these formulas, but we have to understand them so that conceptually we are clear, we can imagine everything in our mind. Okay. So that's the theory of correlation. We are going to see how are we going to calculate this correlation. We're going to take a case study and calculate a correlation. We're going to do a lab exercise now. But before that, let us take quick questions. Please go ahead. Yeah, Alok, please go ahead.
Yeah. So can you please explain this negative point? How the variables can be negatively associated?
So as the temperature increases, so look at the variable temperature and sweater sales. What happens if the temperature increases? Sweater sales increases or decreases? Tell me what happens?
Yeah, decrease, sir.
As the temperature decreases, as it gets colder and colder, what happens to the sweater sales?
It will increase, sir.
So can I say there's a negative relationship between them? Not direct relation. It's an inverse relation, isn't it?
Yeah.
There are some variables that are having inverse relation. Let's say speed versus mileage. Like if you go very fast, then what happens?
Correct, sir.
Yeah. So there are some variables in this world. I'm not saying every variable. There are some variables in this world where the relationship between them is as one increases, the other one actually decreases. Okay.
Yeah. Yes.
Yeah. So if you take an example, house price versus distance from the city center. If you are far away from the city center, what will be the house price? If the distance from the city center increases, the house price. If the distance increases, the house price decreases. If the distance decreases, that means you're closer to city center. What will be the house price?
Increases.
Can you connect to it, all of you? Those two are negatively related. So there are so many such examples that we can think of where one variable increases, the other one is actually decreasing. In that case, the correlation between them would be negative. All right. This is all the theory. What we will do is we will try to what we will get after this analysis. So think of it, Saurabh. There are two variables. You do not know whether they are associated or not. There are two variables, whether two variables are associated or not. Let me give you an example. So look at this case study, then you will understand it. Okay. This particular data set was given by some airline company. They have gathered nearly 1.5 to 2 years data, 1.5 years data, and they have given us this data set. And this is how the data looks like. This is the info of the data. So week on week for 80 weeks, they have gathered the data, nearly 1.5 years, more than 1.5 years, they have gathered the data. This is a real data set. Only thing that I have done is, most of the data sets that we use in this course are real data sets. Only thing that I do is, what happens if you take the raw data? Obviously, you have to spend a lot of time on
Cleaning it.
cleaning. So what did I do? I just cleaned the data and I'm bringing them here. Because otherwise, every time in every case study, we'll be spending a lot of time on cleaning. I just cleaned the data and I got it here. Okay. Now, this is a cleaned version of the air passengers data shared by one airline company. And the data is for around 80 weeks. So we have the columns like week number and number of passengers who use that airlines in that week. How many passengers have used that airline? In 1 week, maybe 50,000, in another week, 40,000, in another week, 30,000, in another week, 70,000. So there are some weeks there more number of passengers were there. There are some weeks where there less number of passengers were there. Okay. Now, what this airline company wants to do is, listen to me carefully. They want to find out what are the driving factors. What are the key drivers? What are the impactful factors that will impact my passengers? In a week, passengers are increasing. Why? In a week, there were less number of passengers. Why? I want to find out those factors. What are the driving factors? Why passengers are increasing? Why passengers are decreasing? Now you have some other variables that are also collected. One such example is promotional budget. The amount of money that is spent on marketing, the amount of money that is spent on giving coupons, offers, etc. Do you think the promotional budget and number of passengers, are they associated with each other or not?
Yes, sir.
Some might be associated.
In general, like if you take our general knowledge, based on our knowledge on the airline industry, what we can say, if you're giving more and more coupons, if you're giving more and more offers on the ticket price, obviously the passengers are going to increase. Is it fair to say both of them are associated?
Yes, sir.
But in this data set, in this portfolio, whether they are associated or not, how do you get to know that?
We have to check the
Correlation.
data.
You have to check the data. You have to use a measure. Which is the measure that you will use, whether these two are really associated or not? आप अपना मन से बता रहे हो. You're telling on your own based on your knowledge that yes, maybe these two are associated. But how do you use statistics, or how do you tell that solidly? By using
Correlation.
correlation. Have you understood that now, Saurabh? Where can we use correlation? Is it clear, Saurabh? Yep. So correlation is used for finding out whether variables are associated or not. If they are associated, not all variables are equally associated. Some variables are very strongly associated. Some variables are weakly associated. Some variables, they are never associated. Okay. Let us look at some other variables. Service quality score versus passengers. Whether service quality, does it have an impact on the passengers? Holiday week, whether it is a holiday week or not, does it impact the passengers? Maybe. Delayed or cancelled flights. If there are more and more delays and cancellations of the flight, does it impact my passengers? Maybe. Inter-metro flight ratio. There are flights between metro to metro cities. There are flights between non-metro to metro cities. Do you think if there are more flights between metro to metro cities, does it impact the passengers count? All these we can only assume, but reality, if you want to check, if you really want to know whether it is a impactful factor or not, what you should do? Who will tell you that? How do you get to know that whether does that really impact passengers or not? By using correlation coefficient. Are you getting a feel of what we are trying to do? All of you, are you with me?
Yes, sir.
Yep. All right then. So let us solve the first question. My first question is, promotional budget versus passengers, are they associated or not? I'm your client and I asked you this question. Hey, promotional budget, passengers, are they associated or not? Can you check that? Okay. So how do you do that? As usual, you will get the data. Remember, before any analysis like this, what is the most important thing? After getting the data, what do we do? Before any analysis, can we take the raw data directly do the analysis?
We need to clean it.
We have to always go for data exploration, data validation, data cleaning. That is always given. Are you with me, everyone? There is no place, there is no project in machine learning where we will be avoiding this. Okay. So next time when you see me directly importing the data, directly I'm doing the analysis, what are you going to imagine? What are you going to assume? If I'm directly taking a data set like this and analyzing it, what are you going to assume out of that?
It is clean.
So I have cleaned it outside. Okay. Yep. Okay. All right. This is the data set. And we are looking at the column names described. Like everybody have their own style of looking at the data. By now you might have got your own style. Maybe you're looking at the shape, maybe you're looking at the head. Some of you may be looking at the describe. Whatever it is, just a quick idea on the data. Okay, doesn't matter. You have to find your own way. Generally, what I do is I look at the shape, I look at the head, I look at the info. Those three are sufficient for me to get a good idea on the data. Now I want to find out the correlation between passengers and promotional budget. How do you find that? There is a direct function in NumPy. You write NumPy dot correlation coefficient np dot cor coef. Write the first variable, write the second variable. Most of the Python code that you write in machine learning would be simply calling a function like this. Very, very rarely you will be creating something on your own. There will be never a situation where you are understanding a machine learning formula and you are trying to write a function to actually get the answer out of that. That never happens. Have you observed it already? Whatever you want to do, most of the times it is already pre-written by somebody. You just need to call that, isn't it? So if you are a little lagging in Python, tell yourself that it's perfectly fine. Python is different, machine learning is different. In fact, tomorrow, like in future, there will be no coding language. Everything will be drag and drop. Is it possible to make this whole machine learning drag and drop based where the results are coming out? You drag the first variable, drag the second variable, hit the correlation button, you are getting the result. Is that possible?
Yes, sir.
Very much possible, isn't it? So focus on the concept. So once you write this np dot correlation coefficient, you will get the correlation coefficient result. Okay. So let's go to our Google Classroom. Anybody having the Google Classroom code link directly, paste it in the chat window if possible. Otherwise, I'll pull that. Anybody already on the code file? Paste it in the chat window. Yes. Thank you, Jagannath. So I'm to, is this the same link everybody is accessing? Perfect. Do not execute a lot of here. Understand each and every line of code. At any point of time, if you're not understanding, quickly stop me. Okay. I'll be explaining you each and every line. But I think already you're comfortable with this. Tell me honestly, these codes are not really difficult for you. Okay. This is importing the packages, followed by importing the data, and execute only until here. Don't go far ahead. Okay. We have discussed only until correlation coefficient. So once you have the correlation coefficient result, then I'll tell you how to interpret that result. So send me a confirmation message in the chat window once you have the correlation coefficient result. I'll explain you that result. All right. When you calculate the correlation coefficient, you'll get a correlation matrix as the output. In that correlation matrix, so right now you have calculated the correlation between passengers and promotional budget. So your output will be a matrix. Columns would be passengers and promotional budget. Tell me, if I have a variable X and I'm finding the correlation with its own, the correlation between passengers and passengers, how much would that be?
So
Any
one.
variable and with its own, like every variable is totally related to itself, correlation will be 1. How about the number here? Correlation between promotional budget and promotional budget.
1 again.
One.
One again. There's no real complexity in that, isn't it? A variable is correlated to itself. Now the number over here indicates what? What does that indicate? The number over here indicates the correlation between
Passengers and promotional budget.
passengers and promotional budget. How much would that be here in this example? How much was that?
0.96.
0.9658. And the number over here indicates what?
The correlation between promotional budget
budget and
and
passengers.
passenger.
The correlation between XY, correlation between YX. Does that differ or it will be same? If you look at the formula, correlation between XY, whether you say X into Y or Y into X or variance of X into variance of Y or variance of Y into variance of X, does that differ? Correlation
No, sir.
between XY is same as YX. So that will be 0.9658. So if I ask you to give me a one-word answer, what is the correlation between passengers and promotional budget? What will be your that one-word answer? It is
Strongly correlated.
It is 0.9658. It means it is strongly correlated. It's always a good idea to tell whether it is strongly positively correlated or strongly negatively correlated also. Isn't it? Why is that important? Because some variables can be strongly correlated, but they can be negative also sometimes. Yes or no? So these are strongly positively correlated. These are the two variables, passengers and promotional budget. I think we already guessed it, isn't it? We already guessed that passengers and promotional budget are strongly correlated. One of the question is, can we take 3 variables to correlate? I think the question he's trying to ask was, can we find the correlation between 3 variables? Correlation is always binary only. You can always take only 2 variables and check whether there is a correlation between them or not. If you look at the, like, in fact, that was one of the interview question. Can I take 3 variables or 4 variables, find the correlation between them? What will be your answer? If you look at the correlation formula, In that, how many variables we can see max to max? We can see only 2 variables. That's why correlation can be found. You can found that between only 2 variables, x and y, or y and x, whatever it is, x1, x2. Correlation between xy is same as yx. Okay. Now this indicates that there is a strong positive association between these 2 variables. Okay. Now listen to this carefully. Look at this.
Sir, I have a question.
Let's go.
Sir, does the code goes this way? Okay, we need to write the target variable first and the independent variable next.
Not necessarily. Let's say if you write promotional budget first, then passengers next. Okay.
Mhm.
Then basically it will come the same way. It will be right now you're calling correlation between xy here, yx here, then it will be yx, xy. It doesn't matter. The order doesn't matter.
Okay.
In fact, you can also verify that, check that, also experiment that. You will get the same numbers because behind the scenes, the formula that is working, okay, whether we call it as xi minus x bar into y minus y bar or the other way around, both of them will give you the similar results. Okay.
Okay.
Now listen to this carefully. All of you, focus on this. Imagine you found this result, okay, and you are going to your client. Always, when you're in machine learning, always imagine that you're working somewhere. Okay, I'm your client, you're working with me. Okay, that's why generally I tend to be rude with you sometimes because clients are like that. So you go to your client, you tell them that I did some analysis. I found that promotional budget and passengers. This is a very serious result, isn't it? What does this 9658 indicate? How do you tell that to a layman? What does that 9658 indicate? Tell me.
So strongly positively
There is a
correlated.
strong positive correlation. So we are saying we found the correlation between promotional budget and passengers. And we found that there is a strong positive association. Using our analysis, we did some correlation and all that indicates that there is a strong positive association. Now I'm your client. I'm responding to you. I'm giving you the feedback. Yes, your analysis is correct. In fact, I'm in this airline industry from past 30 years. We have seen that whenever we spike up promotional budget, whenever we spend a lot, we have seen that the passengers are also increasing. Okay. Your analysis is right. But anyway, I'm aware of it. Actually, we are already aware of it. But anyway, you're doing this analysis. Can you tell me this? Next week, we are planning to spend $500,000, $500,000, $5 lakh on promotional budget. That's our plan for next week. Using your analysis, can you predict how many passengers will come? That's the question the client is asking you. First of all, tell me, is that a fair and related question to our analysis? Is it somewhat connected to our analysis?
Yes, sir.
Makes sense, isn't it? In fact, when we go to our clients, these are the kind of questions that we need to be preparing ourselves, isn't it? Because they will ask us some questions that are near to this territory. So usually they log in at night, isn't it? Like when you're most of the times you'll be working with North American based clients or US or UK based clients. At the end of the day, you will be giving these type of results and they'll ask you a simple question. Sometimes to solve that question, you will be spending in the office until 1 o'clock or 2 o'clock. This is a simple question that the client is asking. What is the question? Since anyway, you're saying that promotional budget and passengers are positively associated. And next week, we are planning to spend $500,000. Can you predict passengers? That's the question. Now, what will be our response? Correlation coefficient. What it can do between x and y. Correlation coefficient will tell you x and y whether they are positively associated, whether they are negatively associated, whether they are strongly associated, whether they are weakly associated. That it can tell you. Yes, it does a good job there. But the formula of correlation coefficient, does it have the power that given the value of one variable, can it predict the other variable? Is it possible? Correlation coefficient, given the value of one variable, can it predict the other variable value?
No,
Is
sir.
it possible? Correlation coefficient formula, it does not allow us to predict the value of another variable given the value of one variable. We have to think of a new methodology. Correlation coefficient is useful until what point? Correlation can tell you only the strength of association between any given two variables. But beyond that, if you want to go for prediction, correlation will say, I'm sorry, I do not have that provision here in my formula where I can predict you and give you the value of the variable that you're looking for. So correlation is useful, but it has limitations. What is the limitation of the correlation? That is one of the entry question. What is the limitation? Correlation cannot be used for prediction. You must think of something else. Let us see what is that. Look at this. Imagine this is a scatter plot between x and y. This is x variable, this is y variable. If I give you a scatter plot like this, and if I ask you, hey, x and y, are they related to each other or they are not?
Related.
They are very much related with each other, isn't it? How can you say that when the value of x is a smaller value, y is also small? As x is increasing, what is happening to y?
Y also
Increasing.
Y is also increasing. When x is a larger value, is y a smaller value or a larger value? It is also a larger value. So it is fair to say x and y are very much related to each other. If you find the correlation between them, you will get a very high value. Is that fair to say? If I find a correlation between x and y here, I will definitely get a very high value. Now look at this and try to answer this question. If the value of x is 30, look at this graph carefully. If the value of x is 30 here, can you tell me roughly the predicted value of y? Roughly.
40.
20.
40.
Roughly where it will be.
39,
Look at that.
40.
It need not be exactly precise,
30,
but
40.
roughly around what?
30,
The
30 to
value of
40.
x
Between
is
30 to 40.
30.
35
What will be
to
the
40.
value of y? Roughly it will be around
35 to 40.
40, isn't it?
Yes, sir.
Most of us are saying it is around 40. That means all of us must be doing something very similar in our brain, isn't it? All of you came up with 40. That means all of us must be doing something very much similar. What did you do? Take a step back, all of you. Take a step back. How did you come to 40 number? How did you come to that? You have imagined a line through this data. Tell me honestly, you have imagined a line through this data. After that, you forgot about the data points. You totally ignored the data points. Then when I told x is 30, then you started drawing this line, and then you started seeing roughly it will be around here. Is that what you thought of, all of you?
Yes, sir.
Yes, sir.
Yes.
We
Yes, sir.
have imagined a line through this data. And then when the value of x is 30, what will be the predicted value of y? That's what we did. This is a line that represents your data. This is a line that represents our data, because there are so many lines here. Why didn't you pick any of these lines? Because they don't represent our data. There are so many lines. Why didn't you pick up those lines? Because this is a line that goes through most of the points in our data. Yes or no? This is a line that goes through most of the points in our data. Most importantly, this is a line that gives us predicted value of y. It gives us predicted value of y at any given x. Is it true? If I would have told you x equal to 20, you would have given me a predicted value roughly. If you would have told
Yes,
you
sir.
x is 40, then also you would have given me the predicted value. At any given x, you would have given me the predicted value of y using this line. This is the line that all of you have imagined. The line that you have imagined is regression line. What is this called? Regression line. Some of you may have heard of regression. Some of you may have worked with regression. Some of you may have never heard of regression, but still intuitively, all of us, we understand regression. If you search for the definition of regression line, what will be the definition? This is what you will get. A regression line is a line that represents our data. A regression line is a line that goes through most of the points in our data. A regression line is a line that gives you the predicted value of y at any given value of x. That is known as regression line. Intuitively, regression line is a line that goes through most of the points in our data. Line. We are saying line and all that here. But in mathematics, you cannot say just a straight line as a straight line. No. In English, it's okay. You can say vocabulary like line. But in mathematics, how a straight line is represented? Every line is represented with an equation. So what's the equation of the straight line? Go back to school days. Tell me, what's the equation of the straight line?
Y is equal to mx plus c.
Y equal to mx plus c. That is a regression line equation. Maybe in some schools it was y equal to ax plus b. All of you, you must be familiar with this, isn't it? Y equal to mx plus c, equation of the straight line. That is the regression line equation. If you can recollect, what c used to be known as in our childhood days? C, we used to call it as
Intercept.
intercept. In some schools it was constant. M used to be known as slope or coefficient of x or slope. Y equal to mx plus c. Right now, we already have the values of y with us. Yes or no? We already have the values of x. Do we have them? Based on that only we have drawn the graph. Are you with me? We already have values of x and y with us. Only thing that we need to find out is m and c. Because if you change m and c, that line changes. If you want to fit a regression line, that m and c is what you need to find out. In fact, though this is the equation of the line, but we do not use this childhood terminology. We generally use Greek letters. So y equal to beta naught plus beta 1 x is the regression line equation. Are these two equations one and the same, or they are different? Can you look at them and tell me? In the place of c, I simply replace that with
Beta naught.
Beta zero.
beta naught, which is known as Intercept.
Intercept.
In the place of M, I have replaced that with
Beta 1.
beta 1, which is known as
Slope or
Constant.
coefficient.
coefficient of X. This is the actual regression line equation you will see in all the literature, books, everywhere. Are you comfortable with this now? Next time when you see this, can you identify this as a regression line equation? All of
Yes, sir.
you, yeah? So this is the straight line equation that we know. This is the regression line equation. Okay. So next time when you see this, are you all comfortable? Beta naught, beta 1. Generally, these Greek letters, somehow, if we are not aware of the concept, when we see something and if we see Greek letters in that, generally our brain doesn't get interest in that. But next time when you see this, are you comfortable with this? Are you absolutely comfortable with this equation? Yeah.
Yes, sir.
Now, connect your case study to this, all of you. Are you all in the air passengers case study? Do you remember the client question? All of you, what did the client ask us in the last meeting? What did he say?
Can we are investing $500 million? Can you predict the
We are
number of
investing
passengers?
so and so promotional budget. Can you predict the passengers? That's what
Number
the
of
client has
passengers.
asked you. Okay, that's why we are learning regression. Now, in your context, can you tell me what is the X variable name? Can you tell me what is the Y variable name in your context?
Sir, why is the target variable? That is passengers.
Is
Yeah,
the
tell me what is
promotional
the X variable first. Tell me what is the X variable?
The
Promotional
amount of
budget.
investment.
Promotional
budget.
budget is X variable. What is Y variable?
Passengers.
Passengers. All of you confirm this. Is that true? Given the promotional budget, are you really finding out passengers, or given the passengers, you're finding the promotional budget? What is given to you? What are you predicting?
Promotional
Given
budget is
promotional budget is
Promotional
given
budget is
and
given.
passengers are
Passengers
predicted.
is what you are predicting. So X and Y is perfect. Now, my question to you is, do you have the historical data of promotional budget with you?
Yes,
Do
sir.
you have the
Yes, sir.
historical data of how many years data do you have? Nearly 80 weeks, 1.5 years data. Do you have it already? Promotional budget? Yes or no, all of you? Clear on that?
Yes.
Corresponding passengers data, do you have it? In that particular week, how many passengers have come? Do you have that data as well?
Yes, sir.
Yeah. All of you, do you have a data set where promotional budget week on week, how much promotional budget was spent? That was given to you. With me, everyone? Week on week, how many passengers were there? That was also given to you. Yes or no? Yeah. So we have X and Y data. That means in this equation, we have X and Y data already. So what is that you need to find out if you have to build a regression line? If you have X and Y data already, what do you need to find out? You need to find the value of beta naught,
Beta naught and beta
which
1.
is known as intercept, and beta 1, which is known as coefficient of X. These two need to be found. So how do you find them? There is a mathematical procedure called OLS. It stands for ordinary least squares. This is an optimization process, OLS, ordinary least square optimization process. What does it do? It will try different values of beta naught and different values of beta 1. What happens when you change beta naught, beta 1? The line changes. Do you agree with that point? Maybe this is a line that is y equal to some 55 plus 1.8x. Maybe this is a line that is some 32 plus 1.2x. Maybe this is a line that is y equal to some 20 plus 1.3x. Do you agree? When I change beta naught and beta 1, the line changes? Yes or no? That's how you define a line. When you change these
Yes.
values of beta naught, beta 1, the line actually changes. So what does this OLS mathematical procedure does? It takes the values of beta naught, distinct values. It takes distinct values of beta 1, tries all the combinations and tries to find the best optimal combination of beta naught, beta 1, such that most of the points, the line is going through most of the points. This OLS procedure will try different values of beta naught, different values of beta 1, tries all those values and finally gives us that pair of beta naught, beta 1, where the line is going through most of the points. The best possible optimal solution will be given to us by OLS. We will be calling that procedure. How do you call that procedure? What is the process of that? In Python, we will be giving our data. So we will call a package. This is the package that we will call. And these are the 2 lines of code. Usually model building, most of the cases, no matter which machine learning model you are taking later on, it is always 2 lines of code only. But that 2 lines of code in the backend, it will be hundreds and hundreds lines of code that will run automatically. So here you say my model is equal to, you can give any name here. My model, like my model, regression model, air passengers model, any name, you can give it any name. My model equal to sm.ols, package.ols stands for ordinary least squares function. Here the function name itself is OLS, formula equal to. Until here it is syntax. You write it as it is. Package.ols.formula equal to. Then you mention to Python, what is your y variable, what is your x variable. Isn't it important for us to tell what is y variable, what is x variable to Python? Because y equal to beta naught plus beta 1 x is very different from x equal to beta naught plus beta 1 y. It cannot randomly take which variable is x, which variable is y. So the syntax there is you write y tilde x. Tilde is part of syntax. On the left hand side, you write what is your y variable. My y variable is passengers. Tilde x. X variable is promotional budget. And where can I find these two variables? Are they two arrays lying outside? Or they're part of a data set? These two variables are a data frame called
Here.
here. So you mentioned that data frame. So go to this data frame. Passengers is my y variable. Promotional budget is my x variable. So at the end of this step, the skeleton equation will be formed in the backend. In the backend, Python will think that yes, in the place of y, I have to take passengers data. In the place of x, I have to take promotional budget data. Then once you say model.fit, different values of beta naught will be tried. Different values of beta 1 will be tried. Different values. Very quickly that will happen in a fraction of a second. 1,000th of a second. Milliseconds it will take, just very, very fast. And the values of beta naught, beta 1 will be captured. Everything will be stored in this model object called fitted1. Okay. Everything will be part of this one. Okay. Then what do? You say fitted1.summary. From this model object, what is that you are getting? So once you say model.summary, by here model building is done. Once you say model.summary, there is a huge summary report that is given to you. Based on the model that you have built, a summary report will be given to you. In that summary report, somewhere beta naught will be mentioned, which is intercept. Somewhere beta 1 will be mentioned, which is coefficient of x. What is x here? Coefficient of, it will be given as coefficient of promotional budget. Both of them together will be under the field regression coefficients. These are called as regression coefficients. Correlation coefficient is different. Regression coefficients are beta naught, beta 1. These are regression coefficients. That will be there in the summary report. Apart from that, in this summary report, when you say fitted in regression, there are several other metrics that are calculated. So you will get a huge summary. You will get a list of values that will be given to you. And there are some metrics that are there in this summary that are very important. Out of them, we have discussed only beta naught, beta 1 until now. But we are going to discuss all other metrics one by one. We are going to discuss all other metrics, because all the other metrics, every metric behind the scenes, it has some theory. I'll explain you that theory. Then we'll understand how to interpret it. As of now, in the summary report, we have discussed two measures, which is intercept and coefficient of promotional budget. So what I want you to do right now is go back to your code file. Are you absolutely clear on this code, all of you? These 4 lines of code, is it clear to you?
Yes, sir.
Yeah. So execute only this code snippet. Don't execute the full code. Okay. Execute only that part of the code snippet and then look at the summary. Once you have the summary, I haven't told you exactly where beta naught, beta 1 are found, but give it a try. Browse through it from top to bottom. And then if there is a place where beta naught, which is intercept, beta 1 promotional coefficient of promotional budget, both of them are given to you. Let me know in the chat window. What is the value of intercept? What is the value of coefficient of promotional budget? Give it to me in the chat window, all of you.
Sir, is there any relationship between slope and means that coefficient?
Both are same.
No, that correlation coefficient I'm talking about.
Correlation coefficient, the exact value of the slope, exact value of the correlation coefficient is unit free. Okay. That means whether the value is in millions or whether the value is in thousands, always the correlation coefficient value is always between -1 to +1. Okay.
Okay.
No matter what is the unit. Whereas the value that you see here, coefficient of promotional budget, it can change based on the value of the variable. Do you agree?
Means there is no relationship.
Yeah, I would say there is no relationship. Direct relationship is not there. Okay. Like basically by relationship, what you mean to say is if I know the correlation, somehow can I derive the coefficient of the promotional budget? If that is a question, there's no way you can derive it. Okay. Let's say if I know this value, can I somehow derive the correlation coefficient? There's no way you can derive it. Okay. So once you go through that output, in the second table, here, regression coefficient table, intercept is 1259.6058. That is beta naught. Coefficient of promotional budget is 0.0695. That is the beta 1 value. Apart from this, there are several other measures as well. Are they important measures? Yes, they are. Are we going to discuss? Yes, we are going to one by one, one by one. I'm going to explain everything. And there are some measures which are not in this, but still important. Those also I'm going to explain to you. Okay. Now, let us write down the regression line equation. What is the regression line equation? Y equal to beta naught plus beta 1x. What is your Y variable? Tell me. What is your Y
Passengers.
variable? Passengers
Passengers.
is equal to, what is your beta naught value? Look at your output. What is your beta naught value? How much have you got?
1259.6.
0.058 plus, what is your beta 1 value?
0.695.
0.0695 into, what is X variable?
Promotional budget.
Promotional budget. This is known as regression line equation. Now, with this regression line equation that you have actually calculated using your data, can you answer the client question? Are you in a position to answer the client question? What was the client question? If the promotional budget is $500,000, $5 lakh, can you predict the passengers? That was the client question. Are you in a position to answer that now?
Yes, sir.
Tell me, all of you go ahead and give the answer to me. Calculate it. Yeah, roughly, not exactly, roughly it will be 36,009 passengers are expected. Since it is taking the input, this equation, it is giving us the output, input, output, input, output. That's why it's called model, or it's called regression model. Since it is taking the input and giving the predicted value, it is predicting and giving us, it is also known as predictive model. It is also known as predictive model. Believe it or not, the same thing, this is known as machine learning model. This is also known as machine learning model. Whenever people hear this term machine learning, especially layman, they think, they take the literal meaning out of it. Machine learning, some kind of, like, everybody imagines some kind of robots, robotics, something is working or machine is working on it. So not really. What is machine learning model, or what is machine learning? Machine understanding the patterns in the data. Machine is understanding the patterns in the data, creating a mathematical equation out of those patterns. We have to creating a mathematical equation out of those patterns, so that we can use that equation for making, predictions. This process is known as machine learning model. That is the main crux of machine learning. Machine understanding the patterns in the data, creating a mathematical equation so that we can use that equation for making predictions. Here the patterns are damn simple. Here the patterns are just around a straight line. Yes or no? Very, very simple pattern. One straight line was sufficient. But do you think all the patterns in this world would be just like a straight line? Every pattern will be that simple? May not be. Sometimes the patterns will be very, very complex. Imagine a situation where you have a car. In that car, you have a lot of sensors. Using that sensors, you are taking a lot of information about how much distance this car is, what is the speed, etc., etc. Based on that, you're going to predict whether there's going to be a fatal accident or not. Using these sensors as input information, you have to predict whether there's going to be an accident or not. If there's going to be an accident, then we want to slow down this car. Is this model available right now in some of the cars? What is this known as?
ADAS function.
ADAS function, isn't it? ADAS. Recently, I think XUV 600 or somewhere in that car, 700, they are actually giving this. I have seen some videos. Some people are playing cards while they were sitting on the steering wheel, because that car has ADAS function where it will predict whether there's going to be an accident or not. Now, do you think the patterns over there will be as simple as this? Do you think regression would be sufficient to actually predict there, or we require a complex machine learning model there?
Complex.
Sir,
machine
we
learning.
require
Where we require
a
a
complex machine learning.
complex machine learning model. Regression is one of the simplest machine learning model. It is machine learning nonetheless. It does make a prediction, but this requires complex machine learning model. In fact, in our course, we are going to build a ADAS system using but complex machine learning model, which are coming up later on. Later on in the course, we are going to get into very, very advanced applications, advanced algorithm. Regression is not the only algorithm. There are other algorithms in machine learning which are very, very complex. We will be able to build a system like this as well. But as of now, we are talking of a very simple machine learning model where everything is around a straight line. The relationship between X and Y is right now linear. Is it possible that every time the relationship between X and Y is always linear? Everywhere this equation is going to work? Is that going to work everywhere? Is there going to be a linear relation every time?
Sir, what
may
is
not
this
be.
36,009?
What is this 36,000? Your client has asked you, right? If I'm spending promotional budget of 5 lakhs, what did the client ask you? Tell me, in our last meeting, what happened with the client? Try to recollect it. Communicate with me.
To check whether the passengers.
No, that's not what he has asked. He asked that and we told that passengers are related to promotional budget. After that, in the next meeting, what happened? Anybody was there in that meeting? Tell me. Client has
They are
also asked.
spending- They are spending 5 lakhs
We
as
are spending
promotional
5
budget.
lakhs. We are spending $500,000. Try to recollect it. We are spending
Okay, sir.
$500,000. What did the client ask?
To
How
predict
many
the number of
pla-
How
passengers.
many
So-
passengers will come? Now, this is the answer to that question. What did we answer? If you are spending $5 lakh, the predicted number of passengers, how many? That comes with
36,000.
36,009. Make sense now?
Sir, thank you.
So what I'm saying is, not always you will have a straight line relationship between X and Y. There will be some cases where there can be a non-linear relation also. Those type of models also we are going to build. As of now, we are starting with simplest of the simplest machine learning model. That is called the regression. We just got started with it. There is a lot in regression that we are going to discuss. But before going there, let us now take a big pause here and take all the questions that are related to this before we move on to the next subtopic. Any other questions on whatever we discussed until now?
Sir, I have a question, but it is little out of context.
Okay. If it
So
is
the-
coming up later on, then try not to reveal it. Okay.
No, it is related to mathematics, sir.
Yeah, go ahead. अरे बहुत डर लगता है मुझे मैथ्स सुन के. बताओ.
No, no, sir. What I'm saying, if the line is passing through the origin,
Hmm.
in that case, the beta will be 0, means beta naught will be 0.
हाँ, right.
And what will happen to beta 1, sir?
Depends on the slope ना. Passing through the origin तक आपने imagine किया. अगर points इधर है, beta 1 accordingly होगा. Points इधर है तो beta 1 accordingly होगा.
मतलब 0 नहीं होगा.
Beta
Means
1
I'm
0.
unable to imagine actually.
So slope of 0 means what? Tell me. The line is
Means the
parallel to
passing
X.
through the
Parallel to
horizontal.
X. Horizontal. Slope 0 line na. Try to draw it. Okay. What will be the line? Y equal to 4. Y equal to 2. Okay.
Okay.
Or in your case, y equal to 0. What is y equal to 0 called? This line is known as
Point.
x-axis. Okay.
Okay, okay.
बट वो थ्योरी में मत घुसो, ठीक है? छोड़ दो इसको. घुसना है तो पूरा सीखना है, नहीं तो छोड़ देना है. Okay. Yeah. आधा अधूरा ना, then it will create unnecessary confusion. Okay. Yeah. Generally, what I suggest is there are different layers of learning. In this layer right now, when you're with me, try to look at the application layer and try to take the theory for granted and try to see where can you apply it, how can you apply it, complete the application layer. After that, do a lot of case studies and apply it at multiple places. In the second phase of learning, that's when you get into the theory layer. Okay. Then by then you already have so many things which you can imagine from the business application point of view. Understanding the theory, connecting the dots would be very easy for you. Okay.
Sir, I have a question.
Yeah, please go ahead.
So based on the target variable, what we have calculated is if we are spending 5 lakhs rupees in promotional budget, then we will be having a predicted amount of 36009 passengers.
Right.
How can we come to know that this is the only variable, promotional budget is the only variable that is going to affect the number of passengers? There might be some other variables.
Other variables as well. That is also we're going to discuss.
Okay.
Like in the given list of variables, maybe there can be a combination of variables. That also we're going to discuss. Here you can think this as one of the simplest or basic estimate. We are going to make it a little more complex. Even before going there, how can we be so sure that this 36,009 is correct answer? Before even going to approve this, let's say you have built a model, but How can you be so sure that this is the right model? For example, right now you have predicted passengers. Look at this, all of you. You have predicted passengers using promotional budget. All right, very good. Predicted Y using X. Let me call that as X1. There's another data scientist who also predicted passengers. But did he use promotional budget? No, he used inter-metro flight ratio. He used this variable. Is there a rule that I have to use promotional budget only, or can I use inter-metro flight ratio also? Is there any such variable, first of all, in the data? Yes, there is a variable called inter-metro flight ratio. Can I use it? Yes, I can use it. Let's call this as model M1. Let's call this as model M2. Let's say using this model, we predicted that next week there will be 36,000 passengers that are going to come. Next week, there will be 36,000 passengers that are going to come. That's what we predicted. Using this model, if this model is also giving us, let's say 36,000 passengers are going to come, there's no problem. But if this model predicts that 15,000 passengers are only going to come, then which prediction I should take? If this model predicts that, no, 45,000 passengers are going to come, which model prediction I should take then? This model is giving this one as a result. This model is giving either 45,000 or 15,000 as a result. Which one I will take? That is why, as a data scientist, whenever you build the model building is only half of the job. Very important point. Make a side note here. Model building only half of the job. Always immediately after model building, you should follow that up with model validation. You have to follow that up with model validation and find out which model is good or whether the model that we have built is doing a good job or not. Model building, anybody can do, any variable can be used, anything we could do in model building. But is the prediction really worthy? That is given by model validation. How good is my regression line that you have built? That is given by model validation. For example, model M1, it is predicting passengers using promotional budget. Model M2 is also predicting passengers using inter-metro flight ratio. It is using a different variable altogether. But which model is doing a good job? How do you know that? So here is the answer. What you should do is you go back to your data set. In the data set, do you have the promotional budget with you already? Do you have the promotional budget? Yes, I do have the promotional budget. In the data set, do you have the passengers count? Actual number of passengers who came?
Yes, sir.
That is called Y actual. Do you have the model now? Model equation is there with you. Can
Yes,
you
sir.
substitute X, get the Y predicted values? Have you ever done? Have you ever tried predicting using a model? Anybody? Have you substituted 5 lakhs? Have you got a predicted value? We predicted, right? Earlier.
Yes, sir.
We made a
39%.
prediction. You substitute the value of X, you'll get the predicted value of Y. We got the predicted values made by model M1. Similarly, repeat the same process, but this time you will take variable X2. Target variable Y actual will be same. Y predictions, but this time the predictions will be made by model M2. These are the predictions made by model M2. These are the predictions made by model M1. Imagine these are the two tables. Predictions made by model M1, predictions made by model M2. If I give you these two tables, if I ask you the question, pick any one out of these two models, a good model out of these two. What will be your answer? Is M1 a good model? M2 a good model? Which is a better model out of these two?
M1.
So M1.
M2, sir.
M1.
M2, sir.
Is M1 a better model? Is M2 a better model? What will be your answer? All of you make an opinion, no
Sir,
problem,
M1.
right or wrong.
M1.
M1, sir.
A
Can't
lot of
say-
you
can't say
unanimously saying M1. Some people are saying M2. Some people are saying can't say. For example, if the actual value is 30,000, if the model is good, damn good, what should be the predicted value? If this model is really good, what should be the predicted value?
Sir, the same
In
as
and around
actual.
30,000.
It has to be exactly 30,000. Otherwise, in and around 30,000. Yes or no?
More than that.
It should be more than that. That means 30,000 predicted should be 70,000 or 100,000 or 1 million. Is that a good model? Actual 30,000 model is predicting 1
No.
million.
No, sir.
No. What is a good model? Whatever is the pattern, it is capturing all of that. Actually, 30,000 model is also predicting 30,000. It is good. In fact, any gap between them can be called as error. Yes or no? This is the error
Yes,
made
sir.
by the model 1000. There is some error here. There is no error here. There is some error here. At every point, there is some error that model M1 is making. At every point, there is some error that M2 is making. But overall, which one is making lesser error overall if you see?
M1.
M1.
M1 is making lesser error or M2 is making lesser error? Overall,
M1.
M1 is making much lesser error. So you have the Y actual value, Y predicted value. Any gap is called as error. Sometimes error is positive, sometimes error is negative. But the overall error for a good model, overall error has to be a
Minimal.
smaller value or a larger value.
Smaller
Smaller
value.
It has to be a smaller value. To get an idea on the overall error, can I simply take the summation of the errors? Does that give me a good idea on the overall error the model is making?
Yes, sir.
Yes, sir.
Yes.
There's a small problem with summation, especially if you have values like this. Some of them are positive, some of them are negative. If you take a simple summation, what's the risk that you will have?
Sir, the values will cancel out each other.
They may cancel out. Always the summation, like even the model is bad, you may not get the right picture. Yes or no? So that's why, what is the solution for this? Instead of taking summation of errors, you should take
The summation of squares.
square of all this. We know that trick, isn't it? Square of all this, take the sum of squares of errors. This term is known as SSE, stands for sum of squares of error. For a good model, sum of squares of error has to be a smaller value or a larger value. Always
Smaller.
it has to be a small value. Do you agree? So when you are comparing two models, you have sum of squares of error for model M1, you have sum of squares of error for model M2. Which model would you go for? Ideally, the model that has
Smaller values.
smaller value of sum of squares of error. That model is picked. If you take the values of Y predicted, take the squares of them. These are known as regression predictions, isn't it? The sum of squares of all those are known as sum of squares of regression predictions. If you take the actual values of Y, take the squares of them. Okay. That summation is known as sum of squares of total. So there is some theory which proves that sum of squares of total is equal to sum of squares of regression prediction plus sum of squares of error. So once again, sum of squares of error has to be as small as possible, as near to zero as possible for a good model. For an ideal model, for an absolutely perfect model, what will be sum of squares of error for an absolutely perfect model?
SST.
Sum of squares of error will be what? For an
Zero.
absolutely perfect model?
Zero.
That will be zero, isn't it? But absolutely perfect model, error of zero may not be always possible. So sum of squares of error has to be near to zero. For a really good model, what should be sum of squares of regression? What should be this value for a really good model?
Should be equal to sum of square of total.
Almost equal to sum of squares of total. Do you believe in this, all of you? For a really good
Yes,
model,
sir.
from the sum of, basically what I'm trying to say is actuals and predictions should match for a good model. Makes sense? So the last question is, for a good model, what should be sum of squares of regression divided by sum of squares of total for a good model?
1.
Always near to, as near to
1.
1 as possible. This is known as R squared measure. There's a name given to it. So for a good model, R squared should be near to 1.
One.
Let's recap whole of this. So sum of squares of error, Y actual minus Y predicted whole square, that should be always, for a good model, that should be near to
1.
0. Sum of squares of error has to be near to 0. And this whole theory, this proves that sum of squares of total is equal to sum of squares of regression plus sum of squares of error. That should be near to 0. That means this should be near to this one. That means sum of squares of regression should be near to sum of squares of total, which indeed means sum of squares of regression divided by sum of squares of total should be near to 1. This term is known as R squared. R squared is equal to sum of squares of regression divided by sum of squares of total. R squared is the model validation measure. When you are building a regression model, R squared. What should be the value of R squared for a good model? R squared value should be near to
Near to 1.
1. The general industry standard, the general practice is, let's say when you join a company, when you are building a model, at least your R squared value, the general industry accepted norm is R squared should be above 80%. At least above 80%, it should be there. Is it possible to get exactly perfect 1 R square, exactly perfect 0 error in the real data sets? Does that happen?
No.
Sir, not so.
Not usual, isn't it? Very, very rare, isn't it? Usually it is okay if your R square is above 80%. At least the minimum to minimum you have to target for R square value of above 80%. That's the general industry standard. Okay. R squared value is the model validation measure. One of the most widely asked interview question is, how do you validate a regression model? Can you answer that now? How do you validate a regression model? Using a measure called R squared. When do you say your regression model is good?
When R square is almost equal to 1.
When R square is near to 1, or what is the general industry standard for R square? What is the general
More
industry?
than, more than 80%.
It has to be above 80%. Now, you have already built a model. Have you built this model using promotional budget? Have you predicted passengers already?
Yes, sir.
Now, do you want me to trust the predictions given by that model? How good is that model? How do you get to know that?
Sir, by R-square.
By looking at the model validation measure, which is R-square. Can you look at R-square and tell me whether that is a good model or not? Can I really trust the predictions given by that model or not? Go ahead,
Yes.
go
On
back
my-
to your code file, go back. You don't need to execute anything this time, isn't it? Have you observed it? You don't need to execute anything. You just go through this, browse through it from top to bottom. Then you will realize that what is the value of R-square? What is the value of R-square, all of you?
0.933.
0.933. Is that a good number? R-square value of 0.933, which means 93.3%
nearby
R-square. Yeah. What
Sir,
is
it is a
general
good
industry
model.
standard? What is general industry
80%.
standard? Above
More than
80%. Is this a good model?
Yes, sir.
Yes, sir.
Can we confidently tell our client that, you know what, 36,000 passengers we are saying, there is a high chance that 36,000 passengers will come. Trust us. Can we say that?
Yes, sir.
Yes.
Now that is model M1. What if I ask you to challenge that model? I'm challenging that model with model M2. Why should I use promotional budget? Why can't I simply use intermetro flight ratio to predict the passengers? That is a different model altogether. I want to challenge that. If you have a competition between M1 and M2, which model will win?
Sir, M1.
Why? What's the reason? Both of them are giving predictions, right? Can I get predictions from M2?
Yes, sir.
Will Python throw an error saying that there will be no prediction from here, or will it give you a prediction?
Sir, it will give us the
But what's the
prediction.
problem with that prediction?
Sir, it is not
R-square.
validated as
It
M1.
is not accurate. If it gives you 30,000 there, you can be so sure about that. But if this model gives you 30,000 here, can you be so sure about it?
No, sir.
No. The answer can be, the real value can be anywhere. The reason is the R-square value of this is how much?
0.242.
0.242, 24 point something is the R-square value. Hands down, which is a better model when you are comparing two models? Which model is better out of those two?
M1.
M1.
The model that has
Better
that
R-square,
has
near to one
near
value
to
R.
1 or the greater R-square value. R-square value is the model validation measure. Do you agree? Anybody can build a model. Any variable can be used for building a model. But the model's respect will increase or decrease only after checking. Only after checking
R-square.
R-square. Don't you think that is very important? Is it fair to say model building is only half of the job? As a data scientist, always model building without fail must be followed by
Model validation.
model validation. And what is the model validation measure in regression?
R-squared.
R-squared.